I'm Sarah Allen. I am the IC3 Community Manager. IC3 is an academic blockchain research initiative, and I'm joined today by Patrick McCorry. Patrick McCorry is an IC3 alumni. He's former assistant professor at King's College London, and he was a postdoc who worked with Andrew Miller and Sarah Michaeljohn, who are both IC3 associate directors. He's now the CEO of PISA Research.
Hi,
So,
everyone.
Patty. So, Patrick, if you could just start by just giving a high-level explanation of what gas is in Ethereum.
So before we get in the idea of gas, what we really should highlight is, what is Ethereum and what is the problem gas is trying to solve? As we're all aware, Ethereum is this global network where we can deploy programs and we can run programs. And to keep it very simple and at a high level, it's a global resource that everyone in the world will share. So it's a bit like a computer from the 1970s that we all have access to. And as you're aware, a computer from the 1970s is slow and expensive, and there's only so much work it can do at any given time. So if we all send transactions at the same time, it's going to get clogged up, it's going to go crazy, and then blue screen and doesn't work. It'll just become very unreliable. So the idea of gas is just a way for us to measure computation, this standard metric. So let's just say adding two numbers may cost 3 or 4 gas. Storing a number on the computer is also going to cost 20,000 gas. And maybe sending the actual transaction is 21K gas. So now we can measure computation in a standard way. We can actually put a restriction on the network, and we say, 1970 computer, you're only allowed to do 10 million gas every 14 seconds. That's your peak processing rate. And that's basically what gas is about, just a way for us to measure computation and then limit what that computer is actually doing.
So let's say I'm sending a transaction to the network. How is the gas fee that I'm going to pay calculated?
Yeah, so that's the really tricky part. So now we have this 1970 computer, this bin, and it can only have 10 million gas every 14 seconds. What we also have is this global peer-to-peer network. And the idea is that I first send my transaction to the peer-to-peer network, and then it'll eventually get processed by this computer. Now, what could happen is that, within 14 seconds, this block, this bin can only have 10 million gas, but at any given time, there could be a huge list of pending transactions that all want to get processed by the computer, by this, this bin, but there's just not enough space. So only some of those transactions are going to get confirmed in the block and then get processed by the computer. So the point of the fee is the whole point of that gas fee is that we're competing with everyone else to get processed by the computer at a certain time. So if you and I send transactions, I'm going to set a higher fee to convince the network to process my transaction before your transaction. So, in a computer science perspective, you just think, abstractly, there's a bin, it can only process, 10 million gas. There could be 200 million gas outstanding, and only 10 mil of that list could, of those boxes could be put in the bin. So we're all competing in that market in order to get in and get processed by that big computer.
And gas is measured in Gwei. So why is gas measured in Gwei instead of in ETH?
Instead of ETH, yeah. So this comes down to so obviously this network has an underlying, I guess it's not very obvious, is it? So all of these networks have an underlying currency. So Bitcoin has, Bitcoin and Satoshis. And at Ethereum, we have ETH and Wei. Wei, I believe, is 18 decimal places of an ETH, and Bitcoin's 8. So 1 Wei is the smallest unit of account for, the ETH currency. It's a bit like a penny. And then the pound or the dollar would be the ETH. The dollar's only 2 decimal places. Ethereum's like 18, I believe. Don't quote me on that. So that's just basically the currency we use to pay for things on the network. And obviously, because it's a currency, there's a conversion rate to dollars as well. So I could buy today 1 ETH for, I think it's $387, around that. And that's how you can buy currency and then start buying stuff on the network or spending your money on the network.
And in July of this year, I think roundabout, gas fees were going crazy. So, there was talk about whether gas fees were going to break the network, and what was going to happen. So why was everything going so crazy?
Yeah, so I mean, I guess to give some context there, when I first started looking at Ethereum in 2016, the network was growing, but it wasn't very popular. So there wasn't really a fee market. When I sent a transaction to the network, there weren't that many pending transactions waiting to get processed. So the network wasn't clogged up. So if I just sent a transaction, there was a very good chance it was going to get processed in the next block within 14 seconds. What happened this summer, and what also happened in 2017, there's so many people who want to use the network at exactly the same time that the network just can't process those transactions. So what happens is that everyone has a pending transaction. You have a pending transaction. I have a pending transaction. Some anon called Sushi Chef has a pending transaction, and we're all competing to get in the block right away. Because we're all competing, and there's just so many. I think at one point, I'm trying to think of the best metric for this. In Ethereum, you could imagine there were, every block's 14 seconds. You could say there was about 100 or 200 blocks worth of transactions waiting to get in at exactly the same time, and they couldn't get in. You only get one block in, not 200. So because there's so much competition to get in right away, everyone's basically bidding in the fee market to outcompete each other. So, I put in $1, I'm going to say process this at $1. You'll then automatically rebid against me at $2, and we just keep going up with this escalator. And that resulted in everyone paying high fees because we're all basically trying to outcompete each other. And there's also one other point to add there. Why was there so much urgency to use the network right away? So Ethereum's very popular for trading. If I want to swap my sushi token, the ETH, and then ETH, the unique token, or some other token out there. If I'm trading currencies, it's because there's some profit to be made. Actually, one good example is my girlfriend got 400 uni tokens for free, and she sold them for $3,000. But the idea is that the longer you wait, it was $3,000 at the time she was trading it, but the price was going down. So if the price is going down, you really want your transaction in quickly because you'll get the high price for the sale, not the low price. So because of this urgency, one, everyone's trying to get in right away. But two, if you're going to make $3,000 profit on a transaction, you're willing to pay up to $3,000 on the network fee, and you're trying to outbid other people. There's really not that, the ceiling for the fee can skyrocket. And that's basically what we've seen over the summer. People were making so much money on this network from trading that they were more than willing to pay a high fee for that transaction.
And you all at PISA Research built a product called AnySender,
Yeah.
which was supposed to address some of these problems. Can you explain how it works?
Yeah, I can give a rough idea. So as we mentioned, sending transactions to Ethereum is a pain in the ass. One, because it has a low throughput as a computer from the 1970s, basically, so it can't process that many transactions at any given time. And two, there's a lot of there's so many pending transactions out there that you're competing with everyone else in the network to get your transaction in right away. Now, for most users who are using like MetaMask or other wallets out there, when you're on your wallet and you hit send transaction, you normally pick your transaction fee at that point and you send it out. Now, typically most users only get one bid at any given time. I send the transaction at 100 Gwei, but then it gets stuck because my fee wasn't high enough. So I either have to manually rebump it myself, and MetaMask normally only shows that button once, or I just don't rebump it and it's just stuck for the next few hours. So for most users, that's a pain in the ass to deal with. And you can imagine why it's a pain in the ass to deal with, because they're competing with everyone else on the network, but they don't have enough information to compete against everyone else. So they're just picking a high fee because the website told them to. And when they send it, it's no longer a good enough fee to get in. So the reason we built any.sender was to resolve that problem. Any.sender is basically the specialized service where we compete in that fee market for you. We send your transaction at a certain fee and we gradually bump the fee until it gets in. So then the user can just hit send transaction. The user doesn't really care how much they're paying for the fee. They just want to pay the best price at any time. And they don't really want to have to worry about rebumping transaction every 2 minutes. And that's basically what any.sender does, is automates that process for them and competes in the market.
So what do you think the future fee market looks like?
The
So do you
future
think
fee
that
market.
do you think that users are going to take on the burden of calculating their fees? Do you think that it will all be automated by tools like AnySender?
Yeah, I think so. I mean, I think for the latter. So I think the issue we've seen over the summer was that relayers do exist, but they're not that sophisticated yet. Even any.sender is fairly simple. You know, we just send it at a low fee and we gradually bump it. It sounds really special, but it's actually just a really simple strategy for competing in that fee market. But as we've seen over the summer and in 2017, because it's left up to the user to compete in this market, and they just one, they lack the information to actually compete effectively, and two, they want to use the network. They don't really want to have to compete in a fee market with other people. What we've started to see is the rise of wallets that natively have that basically have built-in relayers for their users. So some include, I believe Dharma Wallet has one, the Genosis Wallet and Origin Wallet. And the idea on that UI is that I just hit send transaction. It may come up with a fee estimate of what I may roughly pay. But then what happens is that the transaction is given to the relayer, and then the relayer effectively competes in the market on their users' behalf. So we've actually started to see the uptake of relayers for users. And I think long term, most users will probably have a relayer that specializes in this role. This specializes in competing in the fee market on their behalf. Because relayers are, it's a specialized service now, and relayers spend their entire day thinking about how to outcompete other relayers. And when you have that level of specialization, it's not fair for a user to try and compete.
So it sounds like you think the fee market is here to stay.
I think that the fee market is here to stay. And basically, the whole reason this fee market exists is because the network is a scarce resource. There's only so many transactions that the network can process. And because of that, there's always going to be competition to get it, to get your transaction in the network. It's just the question is, what is the bin there? What is the scarce resource that we're competing over? Today in Ethereum is computation. Computation is the bottleneck. Running all these smart contracts in the network is quite expensive. So Ethereum is moving away from computation and going towards just sending data over the network. So it does minimal computation. All we do is send data across the network, and then your bottleneck becomes bandwidth. But there's still a bottleneck. Ultimately, there's only so much data you can send across a large network within a given time period, and then have it mined and confirmed and finalized. So given that there's always going to be some bottleneck, and if you assume that there's a bottleneck and there's transactions that exceed that bottleneck, then you're always going to have some form of fee market there. It just depends, how bad that bottleneck is. So because there always will be some type of bottleneck, it's very likely that this fee market is going to exist. And if it is going to exist, you're going to need some specialized, service to do that. And I actually think long-term what will happen is that, and this is going into the layer 2 world, you'll have this idea of a sequencer. The sequencer creates blocks on their service. So it could be like a website you visit that says Uniswap. They have this layer 2 service. I send all my trades into the Uniswap. And what Uniswap will do is they'll create these blocks of all their trade transactions, and it'll be up to them to get that finalized and confirmed on the network. And so the user won't have a relayer. It will be the Uniswap provider, the sequencer, who sequences those transactions. They'll have a specialized relayer who then competes in the network on behalf of Uniswap, and Uniswap does it on behalf of all their users. I think within a couple of years' time, we'll probably start seeing architecture like that. And then the user won't even, I actually think at that point, the user won't even know about the fees because that'll all be absorbed in Uniswap's profits. So then you can just go in Uniswap trade probably for free, and then Uniswap will take care of paying the fee for you on the network.
Sort of like a traditional bank.
Yeah, exactly. And it's like a traditional bank, except one, everything's verifiable. So you can see exactly what Uniswap's doing, and you can, as a user, you can constrain them as well. So one example is, and 1inch Exchange did this, if I swap on 1inch Exchange, or if I submit a trade, I'm going to get 300 coins. Otherwise, that transaction will fail. I'm always guaranteed the outcome of my trade. But if there's any positive slippage, so there's any possible profit, you know, extra coins, so maybe I get 305 coins from the trade, the operator takes those 5 coins as profit. So a lot of traditional services do this already. You know, you swap dollars to pounds. There's no fee because it's hidden in the exchange rate. A lot of services are probably going to do this long-term, extract value from every transaction. And if they do that, then as a user, I don't have a fee. They're just extracting value from my transaction. And then with all this, you know, value extraction they're doing, you know, they're making so much profit from that, then they can pay the network fee for everyone, for all their users. Oh, and actually the point there is all that's verifiable. I can constrain how much they can extract from me. And the second part is non-custodial. You know, I still won't have to trust them with my funds. I still have to authorize all the transactions myself. So a bit like a traditional bank, except with, you know, trust minimized.
Mm-hmm.
It can still censor me, but I can always just take my coins out.
So do you have any final thoughts about gas, the way that it's currently playing out in the future of the fee market?
Yeah, I mean, I guess I could just summarize. I guess that's my final thoughts. I mean, obviously what we've seen over the years is that most users have been responsible for competing in this fee market. The fee market's only really started to exist over the past 2 or 3 years anyway, and it's not really been that competitive. Long term, I think there's always going to be a fee market because there's always going to be a bottleneck on the network, whether that's computation, whether that's bandwidth. So there's always going to be some competition there. I think relayers are going to play this special role where it's up to the relayer to compete on the fee market on behalf of someone else. It could be the end user, or it could be a third-party service, let's say a Uniswap layer 2, you know, service. And I think long-term it'll probably be services that hire relayers. It won't be retail users. And if a service is hiring a specialized relayer, then, you know, the relayer is doing the job for the service provider like Uniswap, and then Uniswap's basically doing that for their users. So long-term, you know, we started off with users having to pick the fee. Hopefully within the next few years, users won't even know a fee exists because they'll just hit send transaction on their Uniswap layer 2 provider and they take care of everything for them. I think relayers will just play that special role where at first right now they're helping users with wallets. Long term they'll move towards service providers. And it's just a nice little, I guess it's like a nice, neat little role in the network. It's a bit boring underlying infrastructure, but everyone needs their own relayer eventually.
But important. I mean,
Yeah, it's really
it's
important.
not boring if it makes the system work.
Yeah, exactly. Otherwise, you're going to have stuck transactions, and then you're not going to be able to use the network because everyone else competes you. And we sort of see that already with some of the crazy gas, like, you know, gas auctions that are happening on Ethereum. That's probably a discussion for another day.
Yeah. Okay. Well, thank you very much, Patrick. That was really interesting.